Welcome to this SQL tutorial. Today, we're diving into the powerful world of MySQL triggers and automatic database change logging. In this lesson, we will learn how to automatically record database activity using triggers in MySQL. Triggers allow the database to respond automatically whenever certain events occur, such as inserting or deleting records. By the end of this tutorial, you will understand how to create triggers that log employee transactions and maintain an audit trail inside your database. Imagine you are managing a company database that stores employee records. Each time an employee is added or removed from the system, management wants a record of that action. Manual recording is tedious and error-prone. Instead of manually recording these changes, we can use SQL triggers to automatically log these events. This is common practice for security auditing, compliance monitoring, and system debugging. Before creating triggers, we need a table that will store the transaction history. This log table will capture 3 pieces of essential information for our audit trail: a unique log ID, the date and time of the transaction, and a description of the event. Now we create the log table using the following SQL code. Create table log with log ID, log date, and transact name fields. Each time a trigger executes, it will insert a record into this table. Next, we create our first trigger. This trigger will activate after a new employee is inserted into the employees table. This is the SQL code for our insert trigger. Whenever a new employee is added, this code will automatically record the action in the log table. Let's break this down. The trigger runs after insert. For each row means the trigger runs once for every inserted record. The NUW keyword refers to the new employee record being added, allowing us to access the new employee's name. Now we create a second trigger to monitor employee deletions. This trigger executes before a row is deleted from the employees table. Here is the SQL code for the delete trigger. It uses before delete to capture information before the record is permanently removed. We use the OLD keyword, which references the row that is about to be removed. This ensures the employee's name is recorded before the record disappears from the database. Now let's test our triggers by inserting new employees into the table. We insert new employees, Pamela, Tina, and Marcos. Each insert automatically activates the log insert trigger. The trigger records the transaction without any additional commands, maintaining a complete audit log of all employee changes. Welcome to the second part of our SQL triggers tutorial. Today, we'll confirm our previous actions, test the delete trigger, and clean up our database environment. First, let's verify that the new employees from the previous step were successfully added to the employees table. We run the query select star from employees, and the results confirm the new employee records are present. Crucially, as a result of our log insert trigger, these insertion actions were also recorded behind the scenes in our separate log table, creating an audit trail. Now let's move on to testing the second trigger we created, the log delete trigger. To test it, we delete an employee record by running delete from employees where employee_ID equals 5. Before the database physically removes the row, the log delete trigger activates, recording the employee's name and the action timestamp in the log table. With both the insert and delete operations performed, it's time to check our centralized log table to see the full history of transactions. We execute the statement, select star from log, to retrieve all entries from our audit table. The results now clearly show the log history, including the initial employee insertions and the most recent employee deletion. This confirms that both the log insert trigger and the log delete trigger executed successfully, demonstrating the power of automated auditing. Once testing is complete, or if the triggers are no longer necessary, it is good practice to remove them from the database. We start the cleanup process by dropping the log insert trigger using the "drop trigger if exists" command. We repeat the process for the log delete trigger to ensure all demonstration objects are removed. Removing unneeded triggers is important for database cleanliness, preventing unintended automated actions, and maintaining optimal performance. Let's summarize the key concepts we covered in this tutorial on SQL triggers. We learned how to create triggers that automatically respond to both insert and delete events within a database table. We utilized the NUW keyword to access inserted data and the OLD keyword to access records before deletion within the trigger logic. Triggers are essential for automatically recording activity in a log table, which is vital for auditing, data integrity, and security in enterprise systems. To conclude our session on SQL triggers, triggers are a powerful feature, allowing systems to automatically respond to changes and enforce business rules without requiring extra application code. Understanding SQL triggers is an important skill for data engineering, database administration, and back-end development professionals.